Hello and welcome back to Saxon Math. This is lesson 81, Arithmetic with Units of Measure. Recall that the operations of arithmetic are addition, subtraction, multiplication, and division. In this lesson, we will practice adding, subtracting, multiplying, and dividing units of measure. We may add or subtract measurements that have the same units. If the units are not the same, we first convert one or more measurements so that the units are the same. Then we add or subtract. So for example, if you have 2 feet plus 12 inches, you cannot add two different measurements. They have to have the same units. So if you wanted to convert this to inches or this one to feet, vice versa, it doesn't really matter. You could have 2 feet plus 1 foot, because you know that 12 inches is the same as 1 foot, and that would equal 3 feet. Or you could have, in this case, 24 inches, because that's what 2 feet is, plus 12 inches if you left it as in inches, and that would be the same as 36 inches. And you should notice that 3 feet and 36 inches are identical to each other. So you get the same answer regardless of whichever you choose to convert. So 3 feet or 36 inches would be fine. Notice that in each equation in example 1, the units of the sum are the same as the units of the addends. The units do not change when we add or subtract measurements. However, the units do change when we multiply or divide measurements. When we find the area of a figure, we multiply the lengths. Notice how the units change when we multiply. So to find the area of this rectangle, you multiply 2 centimeters by 3 centimeters. The product has a different unit of measure than the factors. 2 centimeters times 3 centimeters would be 6 square centimeters. A centimeter and a square centimeter are two different kinds of units. A centimeter is used to measure length. It can be represented by a line segment, like 1 centimeter. A square centimeter is used to measure area, and it can be represented by a square that has 1 centimeter on each side. 1 square centimeter. The unit of the product is a different unit because we multiplied the units of the factors. When we multiply 2 centimeters by 3 centimeters, we multiply both the numbers and the units. So 2 centimeters times 3 centimeters is 2 times 3, which equals 6, and 2 squared centimeters here, because you have centimeters times centimeters, it would be the same as, or also could be represented like this if you're just handwriting it, or if you could use that superscript there. Instead of writing square centimeters, we may use exponents to write centimeters times centimeters, as in centimeters squared. Recall that we read centimeters squared as square centimeters, or vice versa. So you still end up with the same answer there. Example 2, multiply 6 feet times 4 feet. So this one, you've got the same units already, but notice we're multiplying. That dot means multiplication. 6 times 4 is 24, and then the feet, if you're multiplying the feet, you have to square them. So it's 24 feet squared, or 24 square feet. So when you multiply the numbers, you just get your product, and then you have to write the label as square feet. Units also change when we divide measurements. For example, if we know both the area and the length of a rectangle, we can find the width of the rectangle by dividing. So the area of 21 square centimeters is, we know that this unknown amount, this length, would be simply the division answer of 21 and 7. So 21 square centimeters divided by 7 centimeters will result in 3. And then you notice that because This has square centimeters. It's like having two of them multiplied next to each other. That's what that represents. So this square centimeters is just like having two of those things, square centimeters, centimeters times centimeters. And if you're going to cancel one of them out because there's a centimeter down here, all you're left with is 1 centimeter unit. So that means you'd have 3 centimeters as the final answer. Okay. Example 3, if you have 25 square miles divided by 5 miles, first do the units here. You've got your 25 divided by 5, so that's simply 5. And then you have to recognize this would be like miles times miles in the numerator, and then it's divided by miles in the denominator, so you'd cancel out one of the miles and you'd be left with that as the unit label. So you have 5 miles as your final answer. 25 square miles is the same as 5 miles. Sometimes when we divide measurements, the units will not reduce. When units will not reduce, we leave those units in fraction form. For example, if a car travels 300 miles in 6 hours, we can find the average speed of the car by dividing 300 miles per 6 hours. That's 300 divided by 6, which equals 50. But in this case, we can't take hours and it doesn't cancel each other out. So all you're left with is 50 miles per hour. So the quotient 50 miles per hour is just read that way. Notice that the speed is a quotient of the distance divided by time. So if you have 300 miles per 10 gallons, you would have to divide 300 by 10, which you can see this 0 will get knocked out. That 0, all you're left with is 30 over 1. So the number is 30. And it looks like miles and gallons are two differing things. So this would be miles per gallon. So for every gallon you have, you're going 30 miles. That's what the answer to this one would be. All you have to do is divide the numbers and then the units will not reduce. So the quotient is going to be miles per gallon, 30 miles per gallon. So the word per means for each and is used in place of the division bar in this case. All right, let's try some of these. So simplify 2 feet minus 12 inches. Write the answer or the difference in inches. So for letter A, I want to convert that 2 feet into inches. So I need 24 inches. I know that that's what 2 feet represents, minus 12 inches. And I know what that is. 24 minus 12 is 12. And the answer has to be written in inches as it asks. 12 inches would be the final answer. All right, for letter B, it says 2 feet times 4 feet. So all I have to do is rewrite that problem, 2 feet times 4 feet. And I notice that 2 times 4 is 8, and feet times feet ends up being square feet. So this would be 8 square feet as my final answer on this particular one. And this one also works too. I mean, if you're writing it this way, if you're typing it, this would be the easiest way to type it out. All right, letter C, 12 centimeters squared, or 12 square centimeters divided by 3 centimeters. So I'm just going to start by rewriting this problem. And I'm going to rewrite it like this. I'm going to put 12 centimeters times centimeters in the numerator, and then 3 centimeters here. So now I know that 12 divided by 3 would be 4 over 1, and this centimeter cancels out that centimeter, so all I'm left with is that and this, which equals 4 centimeters. That'd be my final answer there. And then letter D, 300 miles divided by 5 hours. So again, I just do the division here. So I'd have to do 300 divided by 5 for the numbers. I'd see that 6 would go into 30, and there'd be nothing left over. Bring down the 0, 0. So I'd have 60 as the number. This miles and hours, they don't cancel each other out. They are not equal units, so they just have to remain as they are. So miles per hour would be the final answer. 60 miles per hour. If you're going 300 miles in 3 hours, you're driving 60 miles each hour. And that would be it. Excellent work today. Make sure you guys do all of your written practice problems 1 through 30. Remember, it's necessary to do the problems in Saxon math to understand the previous lessons even better and get your practice. All right, have a great night, and we'll see you next time.